right now on Deconstructed. To find out how everyday stuff works, we cut things in half and tear them apart. In this episode, the toilet, an unexpected marvel of physics. The backyard barbecue, innocent patio fixture, or a backyard bomb that's ready to blow. Bathroom scales. Their numbers weigh on us all, but how do these mechanical and digital contraptions really measure up? And finally, the catalytic converter, that mysterious miniature lab that converts harmful car exhausts into harmless vapor in the blink of an eye. Deconstructed. We take things apart so you don't have to. This program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. The toilet. A very practical object that deserves way more attention than it gets. For its design, that is. The toilet is an absolute marvel of physics. It's one of the best examples of the power of the siphon effect. That's what allows the toilet to get rid of so much water and waste so quickly. The toilet uses water to push water, to pull water. Okay, so how does it work? First, the breakdown. There's the bowl, the toilet tank, the flush mechanism, and the refill mechanism. Together, they get the job done efficiently and ecologically. The bowl is a study in physics. Its design allows it to evacuate a large amount of water extremely rapidly. Without the bowl and its unique design, this amazing contribution to modern sanitation would not exist. The key is the siphon effect. The siphon is a pipe with an S-shaped bend molded into the bowl. It keeps the volume of water in the bowl constant and acts as a water seal, preventing unpleasant gases and odors from coming up through the sewer pipe and into the home. If water is added to the bowl little by little, the toilet won't flush. So, when the toilet is being used, the water rises slightly and overflows into the siphon pipe, but not enough to initiate the siphon effect. For that, you need a lot of water all at once to push the water in the siphon over the bend. Dumping a big bucket of water into the bowl will do the trick, filling the siphon and triggering a flush. The water and its contents are siphoned down the pipe, creating the familiar flushing sound. When the water in the bowl is almost all drained, air enters the siphon pipe, stops the flush, and produces that other familiar sound of gurgling. Even with no toilet tank, the toilet could still be flushed by pouring a bucket of water into the bowl. The crucial step is filling up the siphon pipe. Gravity does the rest, thanks to the cohesive forces in liquids. These forces get water molecules to pull on their neighbors when falling from the siphon's high point. It's really gravity, not a change in pressure, that creates the siphon. The tank acts as the bucket of water. When the toilet handle is pressed, a chain lifts the flush valve, uncovering a drain hole. The tank water then rushes out and fills the bowl in about 6 seconds. The water enters the bowl through the holes in the rim and through a hole called the siphon jet, which pushes most of the tank water straight into the siphon tube. The rush of all this water triggers the siphon, which pulls the water and waste down the drain. The flush valve, which has been floating since the toilet was flushed, falls back into place once the water in the tank empties. It closes off the drain hole, and the tank is now ready to refill. Water pressure keeps the valve in place until next time. The direction of water rotation is not dependent on which of the planet's hemisphere the toilet is located, as some would have it. It has more to do with mundane factors like the shape of the bowl, the slant it's on, and the direction of the water entering the bowl. When the tank water empties, a filler float falls to the bottom of the tank and triggers the filler valve. When the float falls, the valve opens. The filler valve sends water in two directions, to the tank and to the bowl. As the tank fills, the float rises, eventually reaching a point where the filler valve shuts off. In case the filler valve doesn't shut off, an overflow tube prevents flooding by sending the extra water into the bowl below. But although the toilet specializes in waste disposal, a leaky toilet can cause waste. A toilet that leaks just 1 milliliter per minute will waste 526 liters of water in a year. In fact, the toilet consumes more than 30% of all the water used in the home, more than any other household device. Over the years, the design of the toilet has been refined to reduce the amount of water needed for a good flush and to make the toilet more eco-friendly. In 1960, the toilet consumed 20 liters of water a flush. Today, new toilets need only 6 liters. That's really taking full advantage of the power of the siphon effect. Speaking of power, ever wonder if your backyard barbecue could blow you and your burgers to bits? We'll bust one apart to find out. $50,000 BTU. You can still hear the salesman's voice. And you bought it. Hook, line, and sinker. But what the heck does that number mean? It's all about the energy. In fact, it's the amount of energy produced by the barbecue when all burners are going full out for 1 hour. Truth is, the barbecue represents a massive amount of energy at high pressure, hooked up to an ignition system. It's basically a bomb waiting to happen. Thankfully, several incredibly clever devices keep it working smoothly and safely. After all, it's the meat we aim to cook, not the chef. Okay, enough yakking. Let's get down to business. Now that it's been gutted, let's run through the innards, shall we? You've got the hose that brings propane to the valves. Knobs controlling the amount of gas that gets to the burners. The cooking surface. Stainless steel vaporizers. The burners. And the ignition system. Propane makes it all work. Yes, it's flammable and dangerous, but it's also highly useful. It's a gas that becomes liquid under high pressure. For safety reasons, propane containers are never completely full. Propane's gotta have room to expand if and when the temperature rises. Even though it's under pressure, the propane's not completely liquid. At the bottom of the container, it's liquid, but at the top of the container, the propane's in gas form. When gas is sent to the burners, some liquid propane becomes gas. Let's move on to safety challenge number 1. Cramming a flammable liquid into a container at 1,550 kilopascals on a day that just keeps getting hotter? Well, you do the math. When the temperature outside begins to soar, having that mandatory relief valve is a welcome plus. When pressure gets dangerously high, the valve crushes a spring, allowing excess pressure to escape. Phew.